Welcome to this explainer. Look, if you're working in IT support or systems administration, you already know that time is literally your most precious resource. Well, today, we're going to reclaim some of it. Whether you're hanging out on a macOS terminal or a Linux shell, writing a genuinely useful automation script absolutely does not take 15 years of programming experience. Seriously, it takes about 15 minutes. We're going to build a tool that does your heavy lifting for you, step by step. Let's get into it. But first, I got to ask you a question. Have you copy-pasted the exact same massive, complex grep command, say, 20 times this week? You know exactly the one I'm talking about. You search your command history, you find that massive string of text, carefully change the date, and hit enter. It's the agony of manual terminal repetition. Hey, we've all been there. But it's time to break the cycle. So, Section 1. Stop copy-pasting your commands. It is officially time to transition from typing raw, repetitive strings into the terminal every single morning to saving them permanently in a reusable, executable file. That's the whole essence of a bash script. Think about it. On one hand, we have the old, error-prone manual way, typing out long grep pipelines daily, risking typos, and just wasting mental energy. No thanks. On the other hand, the new automated way. You literally just type /analyze_logs.sh, hand it your log file, and press enter. It does the exact same work perfectly every single time. That is immediate, massive value right there. Okay, let's dive into this. Section 2, Anatomy of a Bash Script. To get from a totally blank canvas to that magic command, we need to understand the basic building blocks, right from setting up the file to printing text to the screen with the echo command. There's a mandatory life cycle to setting up a new script in your terminal environment. First, you create an empty file, usually ending in .sh. Second, you add a shebang at the very top. And third, you make the file executable. Let's break those down, starting with the shebang. So what exactly is a shebang? It's simply the hash symbol followed by an exclamation mark. In the Linux world, when you put #bin/bash at the very first line of your file, you are giving the system kernel strict instructions. You're basically saying, hey, do not read this as a plain text file. Read this using the bash interpreter. It's a rigid, non-negotiable requirement to make your code run properly. Next up is permissions. Now, Linux is secure by default, which means it actively blocks the execution of new text files. If you try to run your new script right now, you're going to get a big fat permission denied error. To fix this, you just use chmod +x followed by your file name. This manually grants execution rights, turning it from a static document into a runnable program. Moving on to Section 3, Accepting log file arguments. Now that we have an executable file, we really need to make it smart. We definitely don't want to hardcode our log file paths directly into the script, because then it only works for one specific file. We want our script to dynamically process any log file we throw at it. We achieve this using positional parameters. When you run a script and type extra words after it, Bash assigns those words to special variables. $0 is the name of the script itself. $# counts the total number of arguments. But the one we really care about is $1. That is the very first argument you pass to the script, which, for our purposes, will be the name of our target log file. To make our script super readable and self-documenting, we take that positional parameter and assign it to a named variable. So target_log equals $1. Now, quick pro tip, in Bash, you are absolutely not allowed to put spaces around that equal sign. We capture that dynamic input, and now we can just use $target_log anywhere in our code. All right, Section 4, Core Text Filtering Patterns. The foundation is perfectly set, so now we transition into doing the actual work. We're going to string together some common terminal commands to really analyze those logs. Here is our main pipeline. We extract the relevant error messages, complete with their original timestamps using grep. We can optionally count those occurrences using WC-L, which simply stands for word count lines. And finally, we save our results using a redirection operator, specifically those double angle brackets. Now, the absolutely crucial point here is understanding exactly what those double angle brackets do. A single angle bracket completely overwrites the destination file, wiping out your previous work entirely. Not good. The double angle brackets act as an append redirect. They safely add your new data to the very bottom of the file without destroying what was already there. This is vital for maintaining a continuous log history. And this brilliantly illustrates how it all comes together in a single line of code. We're running grep to find the word error inside whatever file is stored in our target_log variable. Then we take that output and append it directly into report.txt. As you can see, our script is growing, line by line, into a highly effective tool. Section 5, Scheduling Scripts with Cron. Now, what's really interesting about this is we've built a great tool, sure, but we're still the ones manually running it. Let's look at a true paradigm shift, handing our finished script over to the system so we literally never have to think about it again. Enter the Cron daemon. Think of Cron as your unseen timekeeper, a little background process running silently on Unix and Linux systems. It wakes up exactly once every minute, checks a scheduled table called a cron tab, and if it sees a task assigned to that specific minute, boom, it executes it automatically. Of course, to communicate with this daemon, we gotta speak its language. Every single cron tab entry starts with a 5-field format representing time and date: minute, hour, day of the month, and day of the week. If you don't care about a specific field, say the month, you just throw in an asterisk, which simply means every. Let's look at a real-world example. 0 space 8 space asterisk space asterisk space followed by the absolute path to our script. This translates to exactly 8 a.m. every single morning. Furthermore, Cron can actually automatically email you the output of this script. That means your fresh log report arrives straight to your inbox without you lifting a single finger. How cool is that? All right, Section 6, a real IT support scenario. Let's see how all this builds into our grand finale. We're going to assemble our final script to scan the last 24 hours of application logs right before your morning stand-up meeting. To make our daily report unique, we need today's date. So we're using a really neat technique called command substitution. By wrapping the date command in a $ and parentheses, the script actually runs the command, grabs the output, in this case the year, month, and day, and stores it directly into our date variable. We now have a dynamic timestamp we can use for our output file. Next, we want to enhance our analysis. We aren't just blindly extracting errors. We want to count them by type to see what's actually broken. We take our grep output and pipe it, using that vertical bar character, into a command called sort. Then we pipe that sorted list into unique-c. The -c just stands for count. This neat little pipeline extracts all the errors, alphabetizes them, and gives us a clean, tallied count of each unique error type. And here it is, the final, elegant 5-line script. We have our shebang, we grab our target log dynamically with $1, we generate today's date, we create a dynamic report file name using that date, and finally, we run our grep, sort, and count pipeline, appending the pristine summary straight into our daily report file. With just 5 lines of code, you've completely replaced 20 manual tasks. It really does take just a few minutes of incremental building. I really want to highlight this quote here. Automation is only effective if it occurs reliably without manual initiation. Think about that. Once you take that brilliant 5-line script and pair it with your 8 a.m. cron job, the human element is totally removed. You never have to execute these commands manually again. The server analyzes itself before you've even had your first cup of coffee. So, I leave you with this final thought. Look at your terminal history today. Look at the commands you find yourself typing over and over every single day. You now have the exact blueprint to stop doing all that manual labor. What repetitive task will you automate tomorrow morning? Dive in, create that .sh file, and take your time back. Thanks so much for joining me on this explainer, and happy scripting.